They told him the American fighter was diving at over 400 miles per hour. Lieutenant Takeo Tanimizu didn't believe it at first. No aircraft could maintain control at such speeds, let alone pull out of the dive without tearing itself apart. But there it was, falling from 30,000 feet like a dark blue Avenger, its inverted gull wings unmistakable even at distance, its Pratt and Whitney engine screaming. Tanimizu pushed his Mitsubishi A6M0 into a dive to follow, throttle full forward, stick pushed hard. His airspeed indicator climbed past 200 miles per hour, past 250, approaching 280. The aircraft began to shudder, control surfaces stiffened, and still the Corsair pulled away, growing smaller, impossibly fast, until it leveled out 4,000 feet below him and climbed back up to attack position, while Tanimizu struggled to pull out of his own dive before his wings folded. It was February 19th, 1945. Over. Iwo Jima, and Japanese pilots were discovering that everything they knew about air combat had become obsolete. The question wasn't whether American pilots were skilled. Japanese aviators respected their opponents' courage and training. The question was simpler and more disturbing. How do you fight an aircraft that can dive away from you at speeds your own machine cannot reach without disintegrating? How do you counter an advantage so fundamental that no amount of tactical brilliance can overcome it? For nearly 4 years, Japanese naval aviation had grappled with this problem. They had tried new tactics, modified their aircraft, trained their pilots differently. Nothing worked. The physics were unforgiving. The Corsair could dive at 400 miles per hour. The Zero could not follow. That single fact rewrote the entire tactical doctrine of Pacific air combat. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Understanding why this mattered requires going back to the beginning, to the moment when Japanese naval aviation believed it had achieved perfection. In December 1941, when Mitsubishi A6M0 fighters swept over Pearl Harbor, they represented the culmination of a decade of careful design and tactical development. The Zero wasn't an accident. It was the product of specific requirements issued by the Imperial Japanese Navy in 1937 for a carrier-based fighter that could escort bombers on long-range missions, maintain air superiority over combat zones, and outmaneuver any opponent it encountered. Mitsubishi's chief designer, Jiro Horikoshi, faced seemingly impossible constraints. The Navy wanted a fighter with a range of over 1,500 miles, a top speed exceeding 300 miles per hour, and maneuverability superior to any existing fighter. They wanted it to carry 2 20mm cannons and 2 7.7mm machine guns, and they wanted it light enough to operate from carriers with short flight decks. Horikoshi achieved these goals through radical weight reduction. He used a new aluminum alloy called Extra Super Duralumin, which was lighter than conventional aircraft aluminum. He eliminated all unnecessary structure, stripping the airframe down to its essential elements. He designed a wing with exceptional lift characteristics, allowing slow landing speeds for carrier operations. He omitted armor protection for the pilot and fuel tanks, calculating that the weight savings would allow the performance the Navy demanded. The result was an aircraft that weighed just 3,700 pounds empty, about the same as a modern sedan. With pilot, fuel, and ammunition, combat weight reached 5,313 pounds. By comparison, American fighters of the same era weighed significantly more. The Grumman F4F Wildcat, the U.S. Navy's primary fighter in 1941, weighed 5,500 pounds empty and over 7,300 pounds loaded. The Zero's light weight gave it extraordinary performance in specific flight regimes. It could turn inside any opponent, completing a full circle in under 16 seconds at combat speeds. Its climb rate at low altitudes exceeded 3,000 feet per minute, allowing it to quickly gain altitude advantage. Its range with external drop tanks reached nearly 2,000 miles, enabling escort missions that seemed impossible to Western observers who couldn't understand how a single-engine fighter could fly from bases in Formosa to targets in the Philippines and return. Most importantly for Japanese tactical doctrine, the Zero was supremely maneuverable at slow speeds. In the traditional dogfight, where aircraft circled each other trying to get on an opponent's tail, the Zero was unbeatable. Japanese pilots trained extensively in this type of combat. They practiced the precise coordination of rudder, stick, and throttle needed to maintain control at the edge of a stall while turning. They learned to use the Zero's extraordinary elevator authority to point the nose quickly at fleeting targets. They developed tactics built entirely around forcing opponents into slow-speed turning fights where the Zero's advantages were overwhelming. This tactical doctrine had deep roots in Japanese military culture and in the specific conditions of the war in China. From 1937 onward, Japanese naval aviation fought against Chinese air forces equipped with Soviet and American aircraft. Early encounters convinced Japanese pilots that their tactics were superior. Chinese pilots, many of them poorly trained, fell easily to Japanese fighters. Even when flying numerically superior forces, Chinese units suffered devastating losses. Japanese pilots accumulated victory after victory, building confidence in their aircraft and their methods. The few encounters, with Soviet pilots during the border clashes at Nomonhan in 1939, provided a warning that should have been heeded. Soviet I-16 fighters, while less maneuverable than Japanese fighters, could dive away from combat when threatened. Soviet pilots used tactics that avoided prolonged turning engagements, instead making high-speed slashing attacks and escaping before Japanese fighters could bring their maneuverability to bear. Japanese pilots noted this in their after-action reports. But the broader lesson was lost. The Soviets withdrew after the conflict ended, and Japanese aviation returned to fighting Chinese forces that couldn't employ such tactics effectively. When war erupted across the Pacific in December 1941, Japanese pilots entered combat with supreme confidence. They had the Zero, which they knew to be superior to anything the Allies operated. They had combat experience from 4 years of war in China. They had tactical doctrine refined through hundreds of engagements. And for the first 6 months, everything confirmed their assumptions. At Pearl Harbor, Zero fighters destroyed American aircraft on the ground and in the air. Over the Philippines, they swept aside the handful of P-40 fighters defending American bases. In the Dutch East Indies, they dominated Australian and Dutch fighters. Over Burma and Ceylon, they defeated Royal Air Force Hurricanes and even the more modern Spitfires when flown by inexperienced pilots. The victories seemed to prove that Japanese aviation had achieved a fundamental superiority. Pilots returned from missions with stories of American and British fighters trying to dogfight with Zeros and dying in the attempt. They spoke of opponents who seemed shocked by the Zero's maneuverability, who couldn't believe a fighter could turn so quickly or climb so steeply. Japanese commanders analyzed these engagements and concluded that their pre-war planning had been correct. The Zero's design philosophy, emphasizing maneuverability and range over protection and firepower, was validated by combat results. But even in these early victories, careful observers noticed something troubling. American pilots who survived encounters with Zeros were learning. They were adapting. Reports from late January 1942 mentioned American fighters that refused to dogfight, that instead made diving attacks and escaped at high speed before Zeros could respond. These were isolated incidents, not yet a pattern, but they suggested that American tactical thinking was evolving. The U.S. Navy's fighter director on the carrier Lexington, Lieutenant Commander John Thatch, was already developing new tactics based on reports from pilots who had survived Zero encounters. He understood something fundamental. If the Zero was superior in traditional dogfighting, the solution was to avoid traditional dogfights. Instead, American fighters should use their advantages: higher diving speed, better structural strength, and heavier firepower. Thatch developed what became known as the WWII, a mutual support tactic where two fighters flew in a crisscrossing pattern. When a Zero attacked one fighter, it exposed itself to the other. The tactic required discipline and communication, but it worked. At the Battle of Midway in June 1942, Thatch's squadron used the WWII to survive against numerically superior Zero forces and shoot down several Japanese fighters. Japanese pilots who encountered the WWII found it frustrating. They couldn't isolate individual targets. Every attack exposed them to counterattack. The traditional tactics that had worked so well weren't working anymore. But Midway was just the beginning. The real shock, the development that would fundamentally alter Pacific air combat, was arriving at forward bases and aboard American carriers in the form of a new fighter. It was larger than the Zero, heavier, more powerful. It had an inverted gull wing that gave it a distinctive profile. It was painted dark blue, almost black, and it could dive faster than any fighter aircraft in the world. The Vought F4U Corsair was about to change everything Japanese pilots thought they knew about air combat. The Corsair's development began in February 1938, when the U.S. Navy's Bureau of Aeronautics issued a request for proposals for a new carrier-based fighter. The specifications were ambitious. The Navy wanted a single-seat fighter capable of at least 400 miles per hour, with heavy armament, long range, and the ability to operate from carrier decks. Vought Aircraft's chief engineer, Rex Beisel, recognized that meeting these requirements would require the most powerful engine available. That engine was the Pratt Whitney R2800 Double Wasp, an 18-cylinder radial producing over 2,000 horsepower. The R2800 was a masterpiece of American engineering. Each cylinder displaced 155 cubic inches. The complete. The engine weighed 2,300 pounds, but produced horsepower figures that seemed impossible to engineers familiar with smaller engines. In its initial configuration, it generated 2,000 horsepower at takeoff. Later variants would produce 2,400 horsepower with water injection. This was nearly twice the power of the Sakai engine that powered the Zero, which produced only 940 horsepower. But mounting such a large, powerful engine created design challenges. The R2800 required a propeller over 13 feet in diameter to efficiently convert its power into thrust. A propeller that large needed significant ground clearance for carrier operations, where aircraft had to land on decks that pitched and rolled with the sea. Beisel's solution was the inverted gull wing, a design where the wing bent downward from the fuselage before angling upward to the tips. This allowed the landing gear to be shorter while still providing adequate propeller clearance. The design added some complexity and weight, but it solved the fundamental problem. The first prototype, designated XF4U1, made its initial flight on May 29, 1940. Test pilot Lyman Bullard pushed the aircraft to 405 miles per hour in level flight during early trials, making it the first American fighter to exceed 400 miles per hour. But high speed alone wasn't what made the Corsair revolutionary. It was what that speed meant in combat, specifically in the dive. Aircraft diving speed is limited by several factors. Structural strength determines how much aerodynamic load the airframe can withstand. Control surface effectiveness determines whether the pilot can pull out of the dive. Engine power determines whether the aircraft can maintain speed or even accelerate while diving. The Corsair excelled in all three areas. Its structure was massively strong, built to withstand the stresses of carrier landings, where aircraft routinely hit the deck at high sink rates. Its control surfaces remained effective at high speeds, carefully designed to avoid flutter or reversal. And its powerful engine could actually accelerate the aircraft in a dive, pushing it to speeds that seemed impossible. Japanese engineers, when they later examined captured Corsair components and reviewed intelligence reports on the aircraft's performance, calculated that the Corsair could safely dive at speeds exceeding 450 miles per hour. Some pilots reported dives approaching 500 miles per hour in emergency situations. The Zero, by contrast, began experiencing severe control problems above 350 miles per hour. The ailerons became heavy, requiring both hands on the stick to roll the aircraft. The elevator stiffened, making it difficult to pull out of steep dives. Above 400 miles per hour, the Zero's structure was in danger of catastrophic failure. Wings could fold upward, ripping away from the fuselage. The tail could tear off. Control surfaces could flutter and disintegrate. This wasn't a minor performance difference. It was a fundamental tactical advantage that no amount of pilot skill could overcome. If a Corsair pilot found himself in trouble, outnumbered or outmaneuvered, he could simply push the stick forward and dive away. No Zero could follow. The Japanese pilot could watch his target escape, helpless, unable to pursue without risking his own aircraft's destruction. He could either break off the pursuit and let the American escape, or continue the dive and likely die when his aircraft came apart around him. The first Corsairs arrived in the Pacific in February 1943, assigned to Marine Fighting Squadron 124, known by the radio call sign Vought Buccaneers. The squadron deployed to Guadalcanal, operating from Henderson Field, the airstrip that had been the focus of months of brutal fighting. Major William Giese commanded the squadron. His pilots were experienced, most, having flown combat missions in other aircraft types. They received their Corsairs with a mixture of excitement and apprehension. The aircraft was larger and more powerful than anything they had flown before. It was also more complex, with more systems to manage and more power to control. The Corsair had a reputation for being difficult to land, particularly on carriers. The long nose obstructed the pilot's view during the landing approach. The powerful engine created significant torque that tried to roll the aircraft left during takeoff and landing. The stiff landing gear had a tendency to bounce on hard landings, sometimes bouncing the aircraft back into the air where it could stall and crash. These characteristics led the Navy to initially restrict Corsair operations to land bases, leaving carrier operations to the smaller, more docile Grumman F-6F Hellcat. But from land bases, the Corsair's characteristics were advantages rather than problems. The long takeoff roll didn't matter on long runways. The landing characteristics could be managed by experienced pilots, and the performance, the speed and climb rate and firepower made every other consideration worthwhile. Marine pilots quickly developed tactics optimized for the Corsair's strengths. They flew high-altitude patrols, using the Corsair's excellent climb rate to gain altitude advantage before engagements. When they spotted Japanese formations below them, they dove to attack, building tremendous speed. They made one high-speed pass through the enemy formation, firing their 650 caliber machine guns, each gun loaded with 400 rounds. Then, instead of trying to dogfight with the more maneuverable Zeros, they continued their dive, using their speed to escape before Japanese fighters could react. If Zeros attempted pursuit, the Corsairs simply extended away, their higher diving speed opening the range until the Japanese gave up the chase. Japanese pilots encountering these tactics for the first time were bewildered. They were accustomed to opponents who either tried to dogfight, which allowed Zeros to use their maneuverability, or who ran away at the first sign of combat, which was tactically ineffective. But the Corsairs did neither. They attacked aggressively, inflicted damage, and then escaped in a manner that was impossible to counter. Zero pilots would pursue, diving after the retreating Corsairs, only to watch helplessly as the American fighters pulled away. Some Japanese pilots, perhaps not fully understanding the danger or determined to press the attack regardless of risk, pushed their dives past safe limits. Aircraft began to vibrate violently. Control surfaces stiffened to the point where pilots couldn't move them. Wings bent upward under aerodynamic loads they were never designed to handle. There are documented accounts of Zeros breaking apart in dives while pursuing Corsairs, wings folding upward and tearing away from the fuselage, tails separating from the aircraft, control surfaces ripping off in the airstream. Pilots who witnessed these structural failures understood immediately what had happened. Their comrade had pushed the aircraft beyond its limits, trying to catch an enemy that was fundamentally faster. The death was not from enemy fire, but from the Zero's own limitations. Squadron combat reports from Marine Fighting Squadron 124's early missions demonstrate the effectiveness of the dive and escape tactic. On February 14, 1943, 8 Corsairs engaged a larger force of Zeros escorting Japanese bombers. The Marines attacked from above, diving through the formation. They claimed 4 Zeros destroyed and 2 bombers damaged. No Corsairs were lost. The Marines reported that Japanese fighters attempted to pursue, but could not maintain the chase once the Corsairs entered their dives. Similar engagements followed over the next weeks. Corsairs attacked, Japanese fighters pursued, Corsairs escaped. The pattern repeated, with deadly consistency. Japanese air commanders on Rabaul, the major Japanese air base in the South Pacific, began receiving troubling reports from their pilots. The Americans had a new fighter that was very fast in the dive. Zeros could not catch it. Traditional dogfighting tactics were ineffective because the Americans refused to dogfight. They attacked and escaped before Japanese fighters could engage them properly. Some pilots suggested that Japanese fighters should avoid diving after Corsairs, recognizing that pursuit was futile and dangerous. But this defensive posture was psychologically difficult for pilots trained to be aggressive, to press attacks, to never retreat. The Japanese Navy's air technical arsenal at Yokosuka received orders to investigate the new American fighters' capabilities. Intelligence officers compiled reports from surviving pilots, from ground observers, from partially destroyed Corsairs that had crashed in Japanese-held territory. The picture that emerged was disturbing. The Corsair was powered by an engine producing over twice the horsepower of the Zero's engine. It was structurally stronger, heavier, better armed. Its diving speed exceeded the Zero's by at least 100 miles per hour, possibly more. The report concluded that Japanese fighters could not effectively counter the Corsair's dive and escape tactics with existing equipment and tactics. Recommendations were made to develop new tactics, to modify existing aircraft to improve their diving speed, and to accelerate development of new fighter designs with better high-speed performance. But implementing these recommendations would take time, months or years. Meanwhile, Corsairs were arriving in the Pacific in increasing numbers. More Marine squadrons received them. Navy squadrons began transitioning from Hellcats to Corsairs for land-based operations. By mid-1943, Japanese pilots faced Corsairs on multiple fronts, and the tactical situation was becoming increasingly desperate. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Lieutenant Saburo Sakai, one of Japan's most experienced fighter pilots with over 60 claimed victories, encountered Corsairs in June 1943 during a mission over the Russell Islands. Sakai had been wounded in August 1942 during a mission over Guadalcanal, losing sight in his right eye and suffering severe head wounds. He had returned to combat duty after months of recovery, though his injuries limited his effectiveness. His post-war memoir describes the frustration of engaging Corsairs with tactics that had worked throughout his career, but were now obsolete. Sakai described attempting to intercept a formation of Corsairs escorting bombers. He and his wingman climbed to altitude and positioned themselves above the American formation, exactly as doctrine prescribed. They rolled into their attack dive, building speed as they descended toward the bombers. The Corsairs reacted immediately, 4 of them breaking away from the escort formation and climbing to intercept. Sakai pulled out of his dive and turned to engage them, confident in his experience and his aircraft's maneuverability. The Corsairs didn't dogfight. The lead aircraft fired a burst from long range, not aiming for a kill but forcing Sakai to break his attack. Then all 4 Corsairs rolled inverted and dove away, not fleeing in panic but executing a practiced maneuver. Sakai attempted to follow, pushing his Zero into a steep dive. His airspeed built rapidly, 200 miles per hour, 250, 280. The aircraft began to shake. The stick became heavy in his hands. He pulled back, straining against the control forces, and managed to level out. The Corsairs were gone, already miles away and climbing back to altitude. Sakai had not fired a single shot. He had not even gotten close, enough to threaten them. They had neutralized his attack without engaging in combat on his terms. Sakai wrote that this engagement, more than any single battle or defeat, made him understand that Japan was losing the air war. It wasn't about pilot skill or courage, it was about equipment. The Americans had aircraft that could choose when and how to fight. Japanese pilots had aircraft that could only fight if the Americans chose to engage on Japanese terms. And increasingly, American pilots weren't cooperating. They used their advantages ruthlessly, attacking when conditions favored them and escaping when they didn't. Other Japanese pilots reported similar experiences. Petty Officer Toshiyuki Sueda, flying from Rabaul in July 1943, described encountering Corsairs while escorting bombers to Guadalcanal. The Corsairs attacked from high altitude, dove through the formation, damaged 2 bombers, and escaped before the Zero escorts could react. Sueda's flight leader ordered the Zeros to pursue. 4 Zeros followed the Corsairs into the dive. 3 pulled out successfully after realizing they couldn't catch the Americans. The 4th pilot, either more determined or less experienced, continued the pursuit past safe limits. Sueda watched the Zero's wings fold upward and separate from the fuselage. The aircraft tumbled through the sky, pieces breaking away, until it impacted the ocean far below. No parachute emerged. The pilot had died trying to counter an advantage he could never overcome. These individual stories, repeated across hundreds of engagements throughout 1943 and 1944, created a cumulative psychological impact on Japanese naval aviation. Pilots who had once been supremely confident now approached combat with dread. They knew their aircraft were inferior. They knew their opponents could escape at will. They knew that every engagement was on American terms, not Japanese terms. The psychological advantage had completely reversed from the war's early days. Japanese aircraft designers attempted to respond to the threat. Kawanishi developed the N1KJ Shiden, a land-based fighter with better high-speed performance than the Zero. It mounted a Nakajima Homare 18-cylinder radial engine producing 1,800 horsepower, giving it a top speed of 369 miles per hour and improved diving characteristics. But the Homare engine was unreliable, suffering from overheating and mechanical failures. Production was limited by Japan's strained industrial capacity and the constant American bombing of factories. Only about 1,000 Shiden fighters were built during the entire war, far too few to affect the overall tactical situation. Mitsubishi developed improved versions of the Zero, including the A6M5 variant, with stronger wing structure, allowing higher diving speeds and better roll rate. The A6M5 could safely dive to about 370 miles per hour, an improvement over earlier models, but still insufficient to match the Corsair. Mitsubishi also developed the A7M Repu, intended as the Zero's replacement, with a 2,000 horsepower Mitsubishi Ha-43 engine. The prototype showed promising performance, with a top speed of 390 miles per hour, but development problems delayed production, and only 9 were built before the war ended. None saw combat. These development efforts, while technically impressive given Japan's resource constraints, came too late and in too small quantities to matter. By 1944, American production had created overwhelming numerical superiority. The US built over 12,000 Corsairs during the war. Vought Aircraft's Stratford, Connecticut plant produced them. Goodyear Aircraft in Akron, Ohio built them under license as the FG-1. Brewster Aeronautical in Pennsylvania built them as the F-3A-1, though quality problems plagued Brewster's production. The point wasn't that every factory produced perfect aircraft. The point was that American industry could afford some inefficiency and still overwhelm Japanese production with sheer numbers. Japan built approximately 10,400 Zeros of all variants from 1940 through 1945. That sounds like a substantial number until you realize it represents total production over 5 years from multiple factories working at capacity. American factories built more Corsairs alone, plus over 12,000 Hellcats, over 9,000 P-38 Lightnings, over 15,000 P-47 Thunderbolts deployed to the Pacific, and thousands of other fighter types. The numerical disparity was staggering. For every Japanese fighter, America produced 5 or 6 or 7 modern fighters with equal or better performance. Japanese pilot training also collapsed under the pressure of losses and resource shortages. In 1941, Japanese naval aviators received over 300 hours of flight training before their first combat assignment. They practiced aerobatics, gunnery, navigation, and tactics until they were genuinely skilled. By 1944, new pilots received perhaps 100 hours of training, sometimes less. Fuel shortages meant less flying time. Experienced instructors were dead or assigned to combat units. The curriculum was rushed, compressed, inadequate. These poorly trained pilots went into combat against American pilots who had 300 or more hours of training in modern aircraft. The combination of inferior equipment and inferior training created a death spiral for Japanese naval aviation. Experienced pilots died. Their replacements, inadequately trained and poorly equipped, died even faster. By late 1944, Japanese air units existed more as theoretical organizations than effective fighting forces. Aircraft that survived one mission often couldn't fly the next due to lack of spare parts or maintenance personnel. Pilots flew their first mission and didn't return from their second. The institutional knowledge that had made Japanese aviation formidable in 1941 was gone, scattered across Pacific islands and ocean floors. The Battle of the Philippine Sea in June 1944 demonstrated the complete collapse of Japanese naval aviation's effectiveness. The Japanese Navy committed approximately 450 carrier aircraft to the battle, launching them in waves to attack the American carrier task force. American carriers deployed their fighters, including dozens of Corsairs and Hellcats, to intercept. The result was what American pilots called the Great Marianas Turkey Shoot. Japanese formations, flying predictable courses at insufficient altitude, were torn apart by American fighters that attacked from above, used their speed advantage to make slashing passes, and escaped before Japanese fighters could effectively respond. American pilots claimed over 300 Japanese aircraft destroyed on June 19th alone, plus another 65 on June 20th. Actual Japanese losses were approximately 350 aircraft over the 2 days, with most pilots killed. American losses were 29 aircraft in combat, plus 76 operational losses, when aircraft ran out of fuel trying to return to their carriers in darkness after a long-range strike. Most of those pilots were rescued. The kill ratio was approximately 12-1 in aircraft destroyed, even more lopsided when considering pilot losses, since many American aviators survived. Japanese carriers limped back to their bases with decimated air groups. Commander Mitsuo Fuchida, the famous pilot who had led the Pearl Harbor attack, was serving as a staff officer during the Philippine Sea Battle. His post-war writings describe the shock among Japanese naval officers when they realized the extent of their losses. The carrier force had effectively ceased to exist as an offensive weapon. The ships remained, but without aircraft and pilots, they were merely floating targets. Admiral Jisaburo Ozawa, commanding the Japanese carrier force, understood this immediately. He wrote in his after-action report that Japanese carrier aviation could no longer challenge American forces in conventional combat. From that point forward, Japanese carrier aircraft were increasingly committed to suicide attacks, kamikaze missions where the pilot's death was the mission objective rather than a risk. This wasn't a tactical innovation born of strategic brilliance. It was a recognition that conventional attacks had become futile. If Japanese pilots couldn't survive combat with American fighters, if their equipment was so inferior that they had no chance of success in air-to-air combat, then the only way to inflict damage was to eliminate the return journey. The aircraft became a guided missile with a human guidance system. The pilot's death was certain, but at least there was a possibility of hitting the target. The kamikaze campaign, beginning in October 1944 during the Battle of Leyte Gulf, represented the logical endpoint of the tactical situation created by aircraft like the Corsair. Japanese pilots couldn't dogfight successfully with American fighters. They couldn't escape from American fighters when attacked. Their only option to inflict damage was to accept certain death and try to crash into American ships before being shot down. Even this desperate tactic was countered by the same aircraft that had made conventional tactics obsolete. Corsairs flew combat air patrols around American task forces, intercepting kamikaze attacks before they reached the ships. The Corsair's combat record in the Pacific was extraordinary by any measure. Vaught's production records and Navy combat reports indicate that Corsairs achieved an 11-1 kill ratio against Japanese aircraft. For every Corsair lost in air combat, Japanese forces lost 11 aircraft. Some squadrons achieved even better ratios. Marine Fighting Squadron 214, the famous Black Sheep Squadron, commanded by Major Gregory Boyington, claimed 97 confirmed victories against 2 Corsairs lost to Japanese fighters during their combat tour from September 1943 to January 1944. Marine Fighting Squadron 215, operating from Torokina Airfield on Bougainville, achieved a 15-1 kill ratio during their combat tour. Major Robert Owens, commanding the squadron, attributed their success to disciplined execution of boom and zoom tactics, exploiting the Corsair's speed advantage while refusing to engage in turning fights with more maneuverable Japanese fighters. His after-action reports emphasized that the Corsair's superiority was not automatic. It required pilots who understood their aircraft's strengths and fought accordingly. Pilots who tried to dogfight with Zeros still died, but pilots who used the Corsair's speed and diving ability correctly dominated every engagement. The technical explanation for the Corsair's diving superiority lies in fundamental physics and engineering. The Pratt Whitney R2800 engine produced 2,000 horsepower. The Corsair's loaded weight was approximately 12,000 pounds. That gave it a power-to-weight ratio of approximately 1 horsepower for every 6 pounds of aircraft weight. The Zero, with 940 horsepower and a loaded weight of 5,300 pounds, had a power-to-weight ratio of approximately 1 horsepower for every 5.6 pounds. On paper, the Zero's power-to-weight ratio was slightly better, but power-to-weight ratios don't tell the complete story. In level flight and climbs, the Zero's lighter weight and more efficient wing gave it advantages. But in a dive, where gravity provides acceleration, the equation changes. The Corsair's stronger structure could withstand higher airspeeds without failing. Its control. Surfaces remained effective at speeds where the Zero's controls became dangerously stiff. Most importantly, the Corsair's powerful engine could add thrust even in a dive, accelerating the aircraft beyond what gravity alone would provide. The Zero's less powerful engine couldn't do this. When diving, the Zero was essentially falling, accelerating under gravity but fighting increasing aerodynamic drag. The Corsair was falling and being pushed by its engine simultaneously. The structural differences were equally important. The Corsair's wings were built to withstand over 7 times the force of gravity in positive G-loads, the stress experienced when pulling out of a dive. The Zero's wings were rated for only 6 Gs, and even that rating was optimistic given the lightweight construction. In practice, Zero pilots were advised not to exceed 5 Gs to maintain a safety margin. When diving at high speed and then pulling back on the stick to level out, the aircraft experienced tremendous loads. At 400 miles per hour, pulling out of a dive generated forces that approached or exceeded the Zero's structural limits. The Corsair, designed for carrier operations where planes regularly experienced high sink rates during landings, could handle these forces easily. Japanese engineers understood these limitations. They had the mathematics. They knew the Zero couldn't match the Corsair's diving performance without fundamental redesign. But fundamental redesign would create a different aircraft, one that would be heavier, less maneuverable, more complex to manufacture. It would abandon the design philosophy that had made the Zero effective in 1941. And even if such a redesign were undertaken, Japan's industrial capacity couldn't produce the high-powered engines necessary to match American fighters. The Nakajima Homare 18-cylinder radial that powered late-war Japanese fighters produced 1,800 horsepower in theory, but reliability problems meant it often produced much less. Mitsubishi's Ha-43 engine, developed for the A7M, produced 2,000 horsepower but never entered mass production. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.